So we have these IV graphs for different types of material. We have the IV graphs for different types of material, so we can explain them in terms of the number of the charge carriers. So the first one is a metal conductor at a constant temperature, or we can also say ohmic conductor. Like we assume that the temperature is not changing. So what is the structure of a metal? The metal consists of a lattice of positive ions and the delocalized electrons. And it is the ideal conductor, means it does not uh, it's having a fixed resistance or a temperature is also constant. So say if the five charges are moving, if we draw the direction of a conventional current, if the five charges are going inside and three charges are able to come out, so the ratio between the number of the charges enter and the number of the charges leave will remain same. So the resistance remain same. Or the ratio between, like if you increase the voltage, the current will also increase, but the ratio between the voltage and current will remain unchanged. But if the temperature increases, as a result of increase in temperature, the lattice vibration increases. Like this lattice vibration increase, they will move faster. So as a result, the number of the charges which are flowing out, that will decrease. So for an ideal conductor, if you increase the voltage, the current will also increase. Why some of the charges stop in the metal? Because the lattice vibration, they collide with the lattice of a positive ion and repelled by the electrons which are already in the structure. That's why the number of the charges which flow out will not be same as the number of charges enter. So for an ideal conductor, if you increase the voltage, the current will also increase. And what the slope represent? The slope represent reciprocal of the resistance. But for the semiconductor diode, as we just discussed now, this is the case. Like initially, why a diode is not conducting? As we know that we have a p-type and the n-type semiconductor, the diode is a combination. So in the beginning, there is a barrier here and the charges need some energy to cross the barrier. So this voltage, the charges does not have enough energy to cross the barrier. That's why the diode was not conducting. Once the charges have sufficient amount of energy to cross the barrier, then the resistance decreases. As you can see, the slope is increasing. So slope and resistance are inversely proportional. So if the slope is increasing, it means the resistance is decreasing. And then again, it will become a constant value. But for a filament, a metal conductor, what will happen? The same idea. Initially, it has a constant resistance, but then the temperature increase. As the temperature increase, the lattice vibration will also increase. When the lattice vibration increase, the number of the charges which enter and the number of charges leave will decrease. That's why the slope is decreasing or the resistance is increasing. Why BR is decreasing? Because the charges, these electrons, like example, 5 electrons are entering, but as a result, they push the other electron to jump. So when more electron jump, so maybe 7 electrons are leaving the structure. When they are able to cross, more electrons are able to jump. That's why the conduction is increasing or the resistance is decreasing. Whereas the thermistor, for a thermistor, as you can see, thermistor is an intrinsic semiconductor. Intrinsic semiconductor means it is already having electrons and holes internally. So as a result, what will happen? As a result, what will happen? Because of the heat or the light energy, the electrons are produced, electron and hole. So as more heat or light, more conduction is there. So in the beginning, its resistance is constant, but then because it become hot, increase in temperature. So if in temperature increases for a thermistor, its resistance will decrease. If the resistance decrease, the slope will increase. So these are the four types of the graphs in terms of their structure. Is it clear? Anyone having a doubt or a question about the IV graphs of metal, ideal conductor, a semiconductor, a filament, and a thermistor?